Alright, so yesterday we did adding and subtracting complex numbers. Today we're going to multiply and divide complex numbers. So that's our goal for today. Now, kind of an important piece of information. We talked about that I equals square root of -1. So if I have I squared, let's just think about that. If I equals a square root of -1, and I want to know what I squared equals, we'll have to square both sides. So I squared is going to equal just -1, because we know that those square and square roots cancel out. That's that big thing right here, is that I squared equals -1, and we're going to use that quite a bit. Now, we're just going to go ahead and multiply these complex numbers. Kind of take it like you would a variable. You have -3i times 2i. So -3 times 2 is -6. I times I is I squared. Now, we know what I squared is from our previous slide. I squared is just -1. So this is really -6 times -1, which is a +6. This concept is going to be important when we start multiplying different kind of complex numbers and dividing complex numbers. So now we're going to multiply complex numbers that have real numbers and complex numbers. This is going to kind of look familiar though. We're just going to go ahead and do 2 times 4, which gives me 8. 2 times 5i, well 2 times 5 is 10, so it's plus 10i. Treat i's kind of like variables in this sense when you multiply them. So we have -3 times 4, which is -12i, and then -3 times 5, which is -15i squared. Now when you multiply them like this, it's going to give you 4 terms. So this should kind of look familiar. Now before we move on, we kind of have to clean some stuff up. Okay. First off, I have this I squared. I know I squared is really -1. Okay, so -15 times -1, that's actually going to be +15. I like to kind of write that in there and then just kind of make a line right there to remind myself, okay, I got rid of that I squared. Now I have real numbers and I have imaginary numbers. Now we're just going to kind of do what we did yesterday and combine like terms. So 15 plus 8 is going to give me 23. And then 10i minus 12i gives me -2i. And there's my answer. Guys, we're dividing complex numbers now. So we're kind of moving on to the next process. The big thing though is you need to know how to multiply complex numbers to divide them. We're actually going to multiply by the conjugate. The conjugate is just when you have, say if you have a plus bi, the conjugate is going to be a minus bi. So it's when you keep the same terms, but you just change the sign that's in between them. So like if I had a -3 plus 2i, the conjugate is -3 minus 2i. The reason why conjugates are important is when you multiply something by its conjugate, it's actually going to get rid of the imaginary number, or those i's. That's going to be important when we're dividing, because you can't have an I at the bottom of your fraction. Now for this first example, if you've noticed, I actually jumping to number 4, not number 3. So we're going to do number 4 first. So what you have to do is we're going to multiply the top and the bottom by a fancy 1. By meaning a fancy 1 is we're just going to need to get rid of those i's at the bottom. So the way that we get rid of i's at the bottom of a fraction is we're going to multiply by the conjugate. So I'm going to multiply by 3 minus 4i. Okay? And you're going to notice something when we multiply by a conjugate. Something happens to the i's at the bottom of the fraction. Now if I do it to the bottom though, I have to do it to the top. So now let's multiply these out. If I do, let's just do the bottom first. 3 times 3, which is 9. 3 times -4i, which is -12i. 4 times I times +3 is +12i. And then 4i times -4i gives me a -16i squared. Okay. Now let's go ahead and do the top as well. So I have to multiply the top. So let me do 3 times 5, which is 15. Then I can do 3 times -2i, which is -6i. I can do -4i times 5, which is -20i. And then -4i times -2i, which is a +8i squared. Now, when I go to simplify this, we got to clean it up a little bit. We know I squareds are really -1s. So let's kind of clean this up. -1 times -16 is actually a positive 16. Okay, same thing over here. -1 times 8 is actually a -8. Okay, now let's kind of clean this up. Let's do the bottom first. I have 9 plus 16, which is going to give me 25. Okay, and if you notice, -12i plus 12i, those just cancel out. So I'm left with just 25 on the bottom. That's exactly what we wanted to happen. That's why we multiplied by the conjugate, is to get rid of the imaginary numbers at the bottom of the fraction. Now let's clean up the top. 15 minus 8 is going to give me 7. And -6i minus 20 is -26i. Okay. Now, your last step is you just got to check to see if that no number can go into all three of these. There isn't a number that can go into all three of those, so that is my final answer. Okay, so now we're back to example 3 on your notes, okay? If you notice, this one's a little different because I just have 3i at the bottom. I'm going to put a 0 plus 3i just kind of as a placeholder because that's going to help me out when I'm doing my conjugate. Okay, so we want to get rid of those i's, so we're going to multiply the bottom by -3i because we want to get rid of that I at the bottom of the fraction. Now let's multiply the top by that same thing. All right. Now, let's multiply the bottom. 3i times -3i, that's going to give me -9i squared. Okay, now at the top, -3 times 12i is -36i squared. -3 times 9 gives me -27i. Now, you can't have I squareds in your final answer. You have to clean that up. So, remember, I squared just is -1. So, let's go ahead and clean this up. -36 times -1 is a positive 36 minus 27i. All that over -9 times -1 is positive 9. Now, this is where I'm talking about you have to look at these three numbers and see if a number can go into all three of them. Well, I notice a 9 can go into all those. So I can divide them all by 9. So I'm actually going to have 4 minus 3i all over 1. Well, really, we don't need that 1 there, so we can just keep it as 4 minus 3i. And notice the real number comes first, and then the imaginary number comes second when you're dealing with complex numbers. And that's our answer. Okay, guys, a term with I is a complex number. Why is a term with I squared not complex? We'll just kind of think about what happens when we have an I squared. What is I squared really? That's kind of my hint towards you. Go ahead and answer that exit ticket and get started on your practice problems.